Hello scientists, we are going to keep studying work and simple machines. We're going to do the Pulleys lab from Unit 6, and that's on the same lab sheet as your levers lab. Here are a couple different simple machines. The pulley is what we're going to work with today, and remember that simple machines don't reduce the amount of work required, absolutely not. Simple machines do reduce the amount of force. They don't reduce the amount of work, they can reduce the amount of force that you need. And the way they do that, by keeping, if they want to keep the amount of work the same, they reduce the force and increase the distance. So here's a pulley that's dear to my heart. I used to work on tall ships, and you can see there are lots of different lines or ropes running through these pulleys here. And the pulleys made little old me able to pull in a half a ton of sail all by myself, because I would have to pull the ropes a long ways, and the boom would only move a tiny bit for all my pulling, but it didn't require as much force. Little old me could pull a lot of mass. In this lab, we're going to look at different setups, different pulley setups that can have different mechanical advantages. So we're going to use a fixed pulley, we're going to use a moving pulley, and then we're going to use a combination of a moving pulley and a fixed pulley. So let's go to the lab and check it out. So to get to the virtual lab, you can use the link on your lab sheet, but if for some reason that doesn't work, go to Unit 6, go to Pulleys 1, click down here through slide 4 of 5, and then click right here. And I highly recommend doing the tutorial for the lab. It will really help you figure things out. So in the lab, we want to use the 500-gram mass. We want to attach it to one end of this fixed pulley here. We want to use the spring scale, hang that on the other end, because that's going to help us measure how much force. And then there are a couple measurements we're going to want to take for our lab sheet, and I'll show you the lab sheet in just a minute. We can see that the mass is at 0 right here. We can zoom in a second. I'll zoom my screen in a bit so you can see the ruler better. You can see that the mass is at 0 on the ruler here. If we go up, we can count the number of black and white sections on the pulley cord, and we see 4 here. And we see that the amount of force on the spring scale is 0.38 newtons. So we're going to go write those 3 pieces of information down on our lab sheet. So scientists, here is the lab sheet on pulleys. It's on the same lab sheet that we used earlier for when we were talking about levers. So just scroll down from the levers part to the pulleys part, and you can read all of this fabulous stuff, and we will start filling this out. So we're using the single fixed position pulley. The starting place of the mass was 0 centimeters. The number of links between the scale and the pulley, remember I counted those black and white sections, was 4 centimeters. Each one of those sections is a centimeter. Mass of the spring scale itself, or actually the force exerted on it by gravity, was 3.8 newtons. Now we have to go and pull up on the pulley to figure out the number of links when the mass is raised, and what the spring scale reads when holding the mass. And we want to raise that 500-gram mass to 20 centimeters. So here we are back in the lab, and we want to grab the spring scale and pull down until the mass is raised to 20 centimeters. And you can zoom in to get a better view of exactly when you reach 20 centimeters. And our spring scale reads 4.90. So we'll have to remember that. 4.90. Now I'm going to have to let go of this for a second so we can zoom in and count those links. So it's like when I pull down, and raise that, oops. I need to go up a little bit. The trick is to not pull, but zoom. We'll have to zoom out a little bit here. Okay. Okay, let's count the number of links. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Maybe you counted differently. You can pause the video and count those links. So I highlighted here what we had already filled in, and we counted 23 centimeters here. Maybe you counted something differently. You can fill that in if you'd like. And the spring scale was it read 4.90 itself. So now we have to work on the single moving pulley. And go record the starting place of the mass, the number of links between the scale and pulley, and the mass of the spring scale itself. So this time we want to take the spring scale down. We'll just set it right there. We want the mass here, and we want to put the mass on the pulley because this is a moving pulley. And we want to hook the spring scale right here. Now we have to zoom in here to see where the mass originally starts originally. We'll go down a bit. And we can see that the mass is hanging at about 3 centimeters. And it's a little bit hard to tell, but the tutorial helps you figure this out. So let's go up. We've got the position of the mass. We can see one white link here showing, so that's 1 centimeter, and we can see that the mass of the spring scale is 0.38 newtons, or that's the weight of the spring scale. Gravity is pulling down on the spring scale with 0.38 newtons of force. So let's record our initial data on the single moving pulley. So the single moving pulley, the initial starting place of the mass is 3 centimeters. We counted the links above the crossbar, and there was 1 link, so that's 1 centimeter. And the mass of the spring scale itself was 0.38 newtons again. So let's go and figure out, let's raise the mass to 20 centimeters and then count the links, and then count the reading, look at the reading on the spring scale. So we're going to go back to the lab and get a couple more pieces of data. So remember, we want to grab the spring scale here, and we want to pull up until we get the mass to 20 centimeters. So the mass is at 20 centimeters. Oops. We need to go up a little bit here so we can read our spring scale. Our spring scale says 2.44, so write that down on your lab sheet under what the spring scale says. That's the last column. And let's count the number of, I'll let you count the number of centimeters, the number of black and white bars that were on the video. You can pause the video when I've got the mass at 20 centimeters and read the black and white bars that are above where the pulley is attached. You want to read the centimeters right here when I've got the spring scale up here and this mass is at 20 centimeters. So you can pause the video and do that. So now we know that the spring scale said 2.44 newtons. And you can count the number of centimeters above that bar in the lab. You're going to have to probably pause the video and count the number of black and white chunks above the bar, between the bar and the spring scale. Now let's go and look at the one fixed position pulley with one moving pulley. So for the third pulley, again, we're going to want to attach the mass to the moving pulley here on the bottom. It's going to start out at 0 centimeters. And we're going to put our spring scale right here. And we end up with the same reading, 0.38. And if you can count here, there are 3 centimeters. There's a black and a white and a white, black, white here. So there's 3 centimeters hanging down here. So we can go record that on our lab sheet. So for the one fixed position pulley and one moving pulley, we had 0 centimeters. We're starting at 0 centimeters. The number of links was 3 centimeters hanging down, and we had 0.38 newtons for the spring scale. So now we're back in the lab, and if we grab our spring scale here and pull down gently, remember we want to raise the mass to 20 centimeters as measured by the ruler over on the stand. We're at about 20 centimeters, and our scale says 2.45, 2.45, and I'll let you pause the video, and you want to look for the number of links that are between the spring scale and the pulley on top. So pause the video and you're going to count the number of links between the spring scale right here, this hook, and here when I've got the spring scale right here. So pause the video and count the number of links between the spring scale and the fixed pulley at the top. So now that you've got the number of links in here and you know what the spring scale said last time, we can scroll down and start filling out this table here. This is the distance the string was pulled. So you want to subtract the initial links and the number of links when the mass is raised. So right here, this is going to be 23 minus 4 for the first one, the single fixed pulley. It's going to be 23, the number of links when the mass is raised, and the number of links between the scale and the pulley. So if we go here, 23 minus 4, that equals 19. And I think I probably counted wrong because it's probably going to be 20 centimeters, the amount of distance we raised the mass. But you can probably do a better count if you pause the video and do the calculations, count the number of links yourself. And we know the effort, the force put in, because we can subtract the force of the spring scale from what the spring scale reads when it's holding the mass. So 4.90 minus 0.38